transformation y equals AF bx minus c. Notice I've got the b outside of this bracket. Here we have all of the transformations. A is a vertical dilation of scale factor A. D is a vertical translation of D units upwards. So it's worth noting here that these two are to do with the vertical. So they'll only affect the y-coords. The x-coords will not be affected, so the graph won't move this way, and there'll be no dilation horizontally. B is a horizontal dilation scale factor 1 over b. C is a horizontal translation of c units to the right. So these two, being horizontal, affect only x-coords. So here I have y is equal to a sine b x minus c plus d. At the moment I have a set to 1, b set to 1, c set to 0 and d set to 0. So that's the standard y equals sine x graph, and we can see that with a maximum of 1, a minimum of -1, and the period of 2 pi. Also we can see it goes through the origin here. So if we change d, we know that that is just a vertical translation. It will move up or down depending on the value of d. If we change the value of a, that's going to change the, let's just make sure it goes in ones, and that's going to change the amplitude. So when the amplitude is 4, it goes up to 4, down to -4. And it's worth noting with those two that they don't impact on each other at all. So if we do that with a equal to 4 and d equal to 2, then the mean line has moved up to 2, so it goes up 4 and down 4 from 2. So a maximum of 6 and a minimum of -2. So let's just put that back to there, and I'm going to leave the a as 4. It's a nice bigger curve for us to look at with the others. So we're now going to look at b and c. Well, we know that b affects the period. So at the moment the period is 2 pi. If I make b equal to 2, then the period becomes pi. If I make b equal to 4, the period becomes pi by 2, and so on. I'm just going to move that back to 1, and then we're going to change c, and I've got c actually going up in pi by 6s here. So if I increase that by 1, it moves to the right pi by 6. Note if I change now b up to 2, it still goes through pi by 6. So we have both a horizontal dilation with a scale factor of 1/2 and a shift of pi by 6, and that's the order in which it's done. So we squashed the curve, then we moved it, and that means the movement is pi by 6. Now there's a reason I'm pointing that out, and I'll come to that now. Now the problem is that you very often get exam questions or test questions where we've not got the bracket here. So it goes bx minus c like that, plus d. Now, if I'm just going to look at this one, what I'm going to do first is just put those constants back. So we'll put b back to 1, and we'll put the c back to 0 like that. So we've got a standard curve other than the fact that we know we've got it dilated, so we've got a bigger curve to look at. So the value of a is still 4 here. Now I'm just going to edit the equation. I'm going to edit it by taking out that bracket there. So if I take out that bracket, I've got to take out one of these other brackets over here, so that we've got the same number of open and closed brackets. And now you can see that I've got what I've written here. Now, watch what happens here if we change the b to 2. Well, exactly what we expect to happen. But if I now change the c to pi by 6, it doesn't go out to pi by 6. If you look here, this is actually only at pi by 12. And the reason for that is that things happen in the other order. What happens is we go out by pi by 6 by changing the c to pi by 6, but then we do the scale factor of a half, and that affects this one as well. It halves it, so it makes it pi by 12. So just be careful with the difference between this and this. Now, personally, when given the choice, I like to factorize so that I've got this top form, because in the top form I know that all 4 of our constants do exactly what we expect them to.